ladies and gentlemen. Welcome to yet another day of e-learning. So I've posted this warm-up for you all. So if you haven't seen it yet on the topic, why don't you pause the screen right now and try to complete this warm-up. So 5 to what power is 125? So you have that list that I've given you before. You've seen some of these powers with solving exponentials. So pause it and give it a shot. Now, once you've unpaused it, hopefully you're doing this. So when you guys are answering these, hopefully I have some help from Ryan. He wanted me to show you guys his bulldozer that he built. So the bulldozer is revealing the answers. So what we're going to be doing today is we're going to be looking at something new, something that you guys, unless you're doing an intense ACT prep class, you probably have never seen before. And what we're going to be looking at today is this. This is our big question. What is a logarithm? Now, some people will explain this different ways, but I like to be able to translate this into other words. So logarithm. Well, there's a lot of things that a logarithm is, but this is what it looks like. And so you see this word log, and then there's a little subscript b. So this says log base b, and that's how we say it. We call it base b of y equals x. Well, right now I'm just looking at it as this equation for you guys, and that this is what a log is, and this is how we say it. But it's honestly not as scary as some people think it is. So if you guys take a look at this here, this is a logarithm. Log base 5 of 125 is 3. Well, if you could do the warm-up, you should be able to understand this. Now, this says, if I was going to translate this mathematical expression into words, this means 5 to what power is 125. Now, we're math people, it's shorthand, but this is what the question actually is asking. And the 3 is the answer. And hopefully that's what you guys got when you did that warm-up that I had given you. So I want to look at how we can evaluate logarithms based on knowing how to rewrite what the question's asking us for. So let's take a look at, now in this second one apparently, but in this problem, we see log base 3 of 27. And if you're just asked to evaluate this, that's what the question's asking you to do. Well, you don't have to write this, but in your mind, I want you guys to be able to go, well, 3 to what power is 27? That's what that question's asking. So if you don't get what it means here, well, just translate it. So 3 to what power is 27? Well, hopefully you guys know that that is 3. Now, in question number 3, well, now we're given the question 4 a little, to what power is 2? Now, 4 is my base and 2 is like what I'm taking the log of. Anytime this number is smaller than your base, you know your answer is going to end up being less than 1. Now, four to what power is 2? So 4 to what power is 2? Well, the only way for me to get to a smaller number is by thinking about roots and cube roots and square roots. Well, it's the square root of 4 that equals 2. And so then it's 4 to the 1/2 that equals 2. So in this case, the answer is 1/2. Now, in our next one, well, if we translate 8 to what power is 8? So 8 to what power is 8? Hopefully you guys are like, Mrs. Dempsey, it's 1. And you are correct. So anytime you guys are dealing with logs and you see when the base and what you're taking the log of, when these match, that's always going to equal 1. And this is something you need to write down. It's one of our properties of logs. It's gonna come back up over and over and over again. So make note of that. All right. So now we get to log base 4 of 64. Log base 4 of 64. So, four to what power is 64? Three. Okay. Now, in these final two here, before I get on to part 2 of this, I want you guys to see this because notice I have log base 4 of 16 and log base 2 of 16. Now, when you guys are looking at these, well, I'm of 16 for both of them, but the bases are different. And that's really important to notice. So in number 6, it's saying 4 to what power is 16? Well, 4 to what power is 16? Well, anybody? Yeah, you guys are right. It's 2. But in this one's asking us 2 to what power is 16? Well, my base is 2 now. So I need to know my powers of 2. So I know 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. So this is going to equal 4. Now, there's one other component of this that I'm going to go through with you guys, and I'm going to come back to these problems to do it. But sit tight. Okay, so now what we're going to do is we're going to start looking at how we can go from exponential form to logarithmic form and vice versa. And so before I show you how to do this, what I want you guys to see though is that you've always had equivalent ways to write things. So we know that this fraction of 1/5 equals 0.2, which is the same thing as 20%. And sometimes one of these forms is better than the other depending on the context that we're in. Now, you guys also have learned how to rewrite expressions so that if you guys had x squared minus x minus 20, you guys know that that expression is the same thing as having x minus 5 times x plus 4. Sometimes we want this expression, sometimes we want this expression, but the whole idea is they're equivalent to each other. And so we're going to learn how to express these exponential and logarithmic functions with equivalent statements. So the first thing I want you guys to see is that this is your logarithmic form, log base b of y equals x. And this is the corresponding equivalent exponential form, b to the x equals y. Now, what we're going to see from this is that this subscript down here, that subscript b, that this is the base of your logarithm and this is the base of your exponent. When we're going back and forth between the two, they're both bases. It's the same base. So the base of the log is the base of the exponent. The base of the exponent is the base of the log. Now, when we've been looking at the logarithms before, we were looking at these and answering these questions like, well, what is my power? Well, the thing is, a lot of people, and I'm one of them, will tell you that a logarithm is an exponent. So when we were answering all of these questions, well, I was looking to figure out what my exponents were. And so when I figured out my exponent, my log was equal to that exponent. So logs are exponents. Now, in order for you guys to convert from one form to the other, I can show you guys some tricks, which I'm going to, but knowing that these are equivalent statements is really important. So we're going to go back and forth and we're going to do a few from one form to the other. Now, if I had given you guys log base 2 of 64 equals 6. Well, to go from log form to exponential form, I've always taught this really stupid trick. I get it. It's gonna be dumb to you guys, but, you know, kids know how to do it. So I could kind of just use this stuff up here, but just to kind of give you some visual support for this, I do what we call canoeing it. I learned this my first year teaching from somebody that I worked with, and it kind of stuck. So this is my canoe. The 2 and the 6 are in the canoe together. You can say that it's a noodle or a cashew or something else, a banana. I've heard it all. I don't really care what you call it, but I use this visually to show me what's going to be on one side of my equal sign. So, and you see how the 2 is lower now? So I know that that's going to be the base of my exponent, 2 to the 6th, and it's equal to 64. Now, if I gave you log base m of j equals r. Well, it's the same thing. Look at who's in the canoe together. So then I'm left with m raised to the r equals j. And the last one for this form, why don't you guys try this one on your own? So do log base 4 of 1/16 equals x. So convert it to exponential form. Hopefully you've paused it already and tried it on your own. So 4 to the x equals 1/16. Well, this is now one of those exponential equations by rewriting the base that you guys did in 7.5, I think. So I know that 16 can get rewritten as 4 squared, and then if I move it up, I get 4 to the negative 2. So I actually know that x is going to equal negative 2. So one way that you guys can evaluate logarithms is by setting it equal to x and converting it and then solving the corresponding equation. All right, and then let me give you 1 or 2 examples of going from exponential form to logarithmic form. So if I gave you 10 to the 4th equals 10,000. Well, there's no trick for this one. There's no uncanoe or canoe backwards or, whatever. But when you guys go to write things in logarithmic form, you're gonna have your log, and then you're gonna have a subscript. And you guys, some of you have terrible handwriting, but you need to know that it's a subscript of some other number equals another number. So this, remember, is your base. Well, the base of the log is the base of the exponent. So right now my exponent is 4 and it belongs to 10, so that's my base. Well, I know that my logarithm is an exponent, and so my exponent was 4, so I'm going to set it equal to my exponent, and that's the stuff I do first. And then I'm like, hey, what's left over? And then I plug it in. But making sure you guys can actually physically write that is important. So like knowing that you're kind of doing this fill in the blank situation there. So if I gave you guys smiley face raised to a star equals a heart. Let's end on a happy note today. So a smiley face raised to a star equals a heart. Like Mrs. Dempsey, those are not numbers, those are not variables. But yes, they are. They're just ones that make us smile. So we're gonna have log base something of something equals something. Well, the base of my exponent, which is the star here, is my smiley face. So that's the base of my logarithm. My exponent's my star, and my log is the exponent. And my leftover is the heart. So, I'm going to leave you guys with some homework, and you need to submit it to Shopee, but you have to submit it to Shopee as a PDF. If I'm ever going to write anything on there, that's the way I need to be able to do it. So, I'll post that. I love you all. I miss you all. Hang in there.